Hey everyone, today we are going to solve the fourth question of our string DSA series, that is longest palindromic subsequence. So in this question, you will be given a string, for example ABAC, ABA, and you have to find the longest palindromic subsequence. Please note that we are finding subsequence, not substring. So a subsequence is basically a continuous string where we can skip one or more characters. For example, an example of substring subsequence would be ABA, ABA. Notice we skipped this C. So we are allowed to skip any character, but we cannot change the order of the characters. So that is the subsequence. And we have to find the longest palindromic subsequence in this particular string. So we'll be using DP in this question. So let's have a look how we are going to approach this problem. So let's suppose we are having a string A. So if I ask you what would be the longest palindromic subsequence if we only consider one character at a time, obviously the answer is 1. What I mean by that is, let's suppose if our subsequence is of length 1, let's suppose we are over here, then at length 1 the maximum possible palindrome would be A itself, which is of length 1. And again at this particular index at B, if we see that what is the maximum what is the longest palindrome that we can achieve if we just have this particular B, again that would be 1. And same goes for this A, C, A, B, A, and so on. So one thing is clear, that if we consider only a single character at a time, then the longest possible palindrome subsequence length would be 1. So if I ask you what would be the length of the longest palindromic subsequence if we consider two characters at a time, then the answer would depend that if this A and B are equal, then the LPS stands for longest palindromic subsequence over here. So the LPS over here would be 2, and if these A and B if these two are not equal, which is A and B in this case, so our answer would be maximum of this A and maximum of this B, maximum of LPS achieved at this position, or maximum of LPS achieved at this position, which in this case is 1 for A also and 1 for B also. So max of 1 and 1 is 1. Okay, so the maximum LPS which we have is 1 over here. Had this B been an A, so the maximum LPS over here would have been 2. So this is the thing, and subsequently we'll use this pointer, we'll call this I and we call this J, and we will move this pointer across the whole string. So in the next iteration, this I and J would now go to B and A over here. So the maximum LPS over here is again 1 because B and A are not equal. We move forward. What is the maximum LPS again here? A and C, again 1. Okay, no problem. What is the maximum LPS of C and 1? What is the maximum LPS over here? 1. What is the maximum LPS over here, which is again 1. Okay, now we will go for 3 characters at a time. Now if I ask you what is the maximum LPS in this case, so in this case we are already having A and A forming an LPS for us. So we already have 2 characters that are contributing to our LPS. Now we just need to find out what was the maximum LPS achieved or computed uh, between 0 and 2 I at the 1th place, that was 1, we computed in the previous iteration. So in this case it would become 1. So the final maximum LPS we can achieve is 3, and which is also true in this case. ABA is a palindrome and it is also a subsequence of length 3. Great. Now we again move our pointer one step ahead. So we are now over here. We see that BAC, are B and C equal? No, they are not. So what would be the maximum LPS achieved in this case? Surely B and C are not contributing anything over here. So the maximum LPS can be either from this index to this index, from 1 to 2, or from A to C only. So either these two will form a palindrome, or either these two will form a palindrome. And that too we have to compute that what was the maximum LPS achieved in this range, or maximum LPS achieved in this range. So we see that again we have computed that in B and A what was the maximum subsequence, which is again 1, and what was the maximum subsequence maximum LPS achieved in this case was again 1, because BAC none of them are matching. So in this case our answer would be maximum of this or maximum of this, and both are equally evaluated to 1. So maximum of 1 and 1 would be 1. So maximum palindromic subsequence would be of length 1 over here, and subsequently will do for each and every iteration. Okay, let's increase our length to 4 characters and see what is happening. So in this case again we see that A and C are not matching. Okay, so what's the scenario now? The scenario is that now the LPS will be achieved from this index to this index, from 0 to 2, or our maximum LPS can be achieved from this pointer to this pointer. And we have to take maximum of these 2 pointers, because A and C are no way because A and C are not matching. So there's no point having there's no point in seeing a palindrome from 0 to 3. Either we have to take palindrome from 0 to 2, we will see what is the maximum LPS, or we will see what is the maximum LPS achieved from 1 to 3. So in this case we see that our maximum LPS achieved in 0 to 2 is 3 ABA, and from 1 to 3 BAC we see that only 1. So the maximum of 3 and 1 is 3. So the maximum LPS can be achieved from ABAC would be of length 3. We see that if we omit C character, then the maximum LPS will be ABA again. So this is the idea behind solving this question, and we would be following this algorithm to solve this question. So let us erase all these pointers over here. Okay, so now we will create a DP table I and J. So I and J are nothing but basically the pointers that we were setting while in the demo. Like we were having I and J pointer here, and we were considering whatever subsequence can be found between I and J boundaries. So I and J are being so the table is so a DP table is created with I over here and J over here. I goes from 0 to 6, which is the length of the string, and J also goes from 0 to 6, which is the length of the string. We saw that I was going from 0 to 6 also, and J is also going from 0 to 6. So this is the DP table we created for each and every iteration. Okay, so this algorithm states that if the characters at ith and jth position are same, if the characters at ith and the jth position are same, we already have 2 characters that contribute to the sequence, which is 2 plus we want to find the maximum subsequence, palindromic subsequence, that was achieved in this particular region, which was I plus 1 and j minus 1. So we do 2 plus dp of I plus 1 and j minus 1, and the value returned from here would give us the maximum LPS in that particular scenario. So if our string matched, we do this. If our strings if our characters didn't matched, what we have to do is, we saw that if our pointers were at A and C, so A and C didn't matched, so we saw that we were considering maximum LPS from this index to this index, which is basically I to j minus 1. The I is over here, j is over here. So we will see maximum LPS from I to j minus 1, or we will find a maximum LPS from this index to this index, which is I plus 1 till j. So this is what we are doing. So we are finding LPS from dp of I plus 1j, I plus 1j, and dp of I till j minus 1. This is j minus 1. So whatever the maximum value will be achieved over here, that would fill our dpij. Okay. So let us do a dry run of this, and we try to fill our dp table. Okay. So in the first case, we were considering only individual characters. So our I and j were at the same place. So I is also over here and j is also over here. So how many maximum subsequence you can achieve if we have only one character, which is 1? So I 0 j 0 we will fill with 1. How many? Then we change I j to over here. How many maximum subsequence you can achieve if we have only one character at this position? So we have only b as the character, so we can only have one maximum LPS. So again we will have 1 over here. Again we move I and j. Again with the same case, and this would be the same case for all the characters. So for all the diagonal characters matching indexes, we will fill the value with 1. So for 2, 2 it will be 1. For 3, 3 it will be 1. For 4, 4 it would be 1. 5, 5 it would be 1. 6, 6 it would be 1. Okay. So these are the indexes telling that we will have only one maximum of 1 LPS if we consider only one one character at a time. Now what is the scenario if we take 2 characters at a time? We have I over here, we have j over here. So now let us see that, is I comma j matching? No, it is not matching. So we come to this place. We find the maximum of dp of I plus 1j. So we are over here. I is 0, j is 1, I is 0, j is 1, and in this place our value will be computed from dp of I plus 1j. dp of I plus 1, we move one character down and we move, we are at the same j. So dp of maximum of this index or maximum of dp of I j minus 1. So j minus 1 over here. So maximum of these two value will be computed. So that is the same case. We saw that if I and j are not matching, then we go from I plus 1 to j, or we go from I to j minus 1. Okay. So maximum of these two is again 1. So if it is not matching, then maximum of, so we have to, while filling the table, we have to remember that if the value is not matching, then the value filled would be maximum of these two columns. Okay. And if the value is matching, then the value would be 2 plus value of this particular column, dp of I plus 1 j minus 1, dp of I plus 1 j minus 1 over here. If the case is matching, if not matching, then maximum of this column, this cell and this cell. Okay. Next we move our I and j. Again, let's do it quickly. We are moving I and j over here. We saw that b and a are not equal, so we have to fill maximum of this value and this value, which would be 1. Okay, move our index. A and C. So A and C are equal? No, they are not equal. So the value filled over there, maximum of this one, maximum of this value, maximum of this value, it would be 1. Okay. Now we move to next again. C and A again not matching. So maximum value would be maximum LPS in this pointer will be maximum of this and this, which is 1. Okay. Move ahead. A and B not matching, maximum of this and this, 1. We move to this index. A and B not matching, maximum of this and this is 1. Great. We were considering 2 characters at a time. Now what about for length 3? How much LPS can we get? So A and A, we are I is at 0, J is at 2, I is at 0, J is at 2. So what is the maximum LPS you can achieve over here? So we have 0 and 2, A and A matching, I and J matching. So str of I and str of J are matching over here. So value will be 2 plus value of this column, so which would be 3. Okay. Next we move to this. B and C are not matching, so maximum of this value and maximum of this value, which is 1 in this case. Next, ahead 3. So we are again doing A and A are matching. Great. So A and A are matching. The value would be 2 plus of this value. 2 plus 1 would be 3 over here. Great. We again move our character 3 step ahead. C and B are not matching, so we are over here. Do maximum of this, which would be 1 over here. Now we are at this place. A and A are matching, so maximum would be 2 plus of this value, which would be 3. So we are done with the so we are done with length 3. Now it's time to jump to length 4. 1 2 3 4. Okay. So A and C are not matching. So in this case, what would be the value? The value would be maximum of this and this, which is 3 in this case. Okay. 4. We see that B and A are not matching, so the value would be maximum of this value and this value, which is 3 in this case. Next we move ahead. 4 A and B. So A and B are not matching. So in this case, not matching, the case would be maximum of this value, which is 3 in this case. Move ahead. See that C and A are not matching, so it would be maximum of this value and this value, which is 3 in this case. We are done with the length 4. It's time to move to the length 5. 0 to 4. So A and A are matching. Okay, so the value would be 2 plus of this, 2 plus of value at this cell. So 2 plus 1, 3. Next we move from 1 to 5. So B and B are matching, so the value here would be 2 plus value of this value, so it would be 2 plus 3, which would be 5. Good. And can move to 2 to 6. So A and A are matching, so the value here would be 2 plus of this particular value, which is 2 plus 1, it would be 3. Okay, we are done with the length 5. It's time to jump to the length 6. So in the length 6 we are going from 0 to 5. A and B are not matching, so here the value would be maximum of 3 or maximum of 5. It is 5. Next we move to length B and A. So B and A are not matching, so the value here would be maximum of 5 or 3, which is here 5 in this case. Okay. Next we move all in. We are going to length 7. A and A are matching, so the value here would be 2 plus of value of this space, which is 5. So the value here would be 2 plus 5, which is 7. Great. So we have filled our table with all the values, and we see that this particular row tells us the value of LPS at any particular from any particular index. So if we want to find maximum LPS that can be formed from 0th index to 5th index, so the value would be 5 over here. Okay, so the string from index 0 to index 5 is A, B, A, C, A, B. Okay, we can see that if we remove A from this index, then this particular thing becomes a palindrome of length 5. 1, 2, 3, 4, 5, BAC, AB, BAC, AB. So our DP table is telling that from 0 till this index, this is the number of maximum LPS you can find. So our question says that we have to find the LPS in the whole string. So for the whole string, the answer lies in this cell, which is dp of 0 n minus 1, which is a 6 over here. Then the value is 7 in this cell. So we can have a palindrome of length 7, which would be a subsequence. So this was the overall logic in this question. Now let's jump to the code. Okay, so this is the code for the LPS question. So we have this function calculate LPS, which is accepting the whole string as the input, and we are storing this length of the string in the n, and we are creating our DP array with this line. So what we are doing is that we are declaring an array of length n. So it will create a 1D array of length n, and we are filling all the values in that array with 0. Okay, that's fine. Now we are mapping to every element of that particular array, and since we have to create a 2D array, so we are iterating, and again inside that particular array we are creating an array of size n, which is filled with value 0. So in this case we created our 2D array, and this is a very standard way to create arrays in JavaScript. So what we are doing is that we are filling all the values of dpi and I, like all the diagonal values, with 1, and we are creating a gap. The gap is basically nothing but the amount of characters that we want to consider at a time, like it be 2 characters at a time, or there are 3, 4, 5, 6. So the gap between the characters which we saw in the diagram, so that is the value over here. So our gap is 2, and we are incrementing gap till n, and we are having a variable I and j. So I starts from 0, and it will move way up to the value of n minus of gap plus 1, and our j is I plus gap minus 1. And this you can easily figure it out if you have a close look at the DP table. You can easily compute the value of I and j from over there. Okay, and we have this our logic that if our str of I equals to str of j, then dp of I of j would be 2 plus dp of I plus 1 and j minus 1. We are shrinking the index, and if our characters are not matching, then dp of I and j would be math or mat.max dp of I plus 1 to j, or dp of I of j minus 1. This is the standard logic, and at the very end we are returning the value that was at the very top right corner, which is dp of 0 n minus 1. The time complexity of this solution is big of n square, because we are iterating first of all this loop, which is big of n, and we are also iterating over here from I to n. So we have 2 for loops that would compute our time complexity to big O of n square. So that was all in this video. See you in the next one.